All right, Logan, part two to the video. We're going to try to knock out 8 through 15. Okay, so identify the given arc as a major arc, minor arc, or semicircle, then find the measure of the arc. Before I do problems like this, what I like to do is just figure out what all the arcs are. So we have 120 here, 60 here, and 60 here. That's a total of 240 plus this right here, 65. That's going to give us 305. This needs to add up to 360. So this right here is going to be 55 degrees. Now we have all the arcs, and now we're going to find arc NM. So I'm going to grab a highlighter here. NM is just this guy right here, the thing we just found. That is a minor arc because it's less than half the circle. So this one here, we would call it a minor arc. And we also know the measurement is 55 degrees. So it's a minor arc with a measure of 55 degrees. Next, JLM. So there's J and there's M. And I need to make sure that I go through M. Oops, sorry. Yes, I need to make sure that I go through L to get there because L is the middle one. Since L is right there, I'm going to start at J, go to L, and then finish off at M. So I need to add up all those arcs right there. So that's 120 plus the 60 plus the 65, which comes out to 245. But before we write anything down, we're going to say that that's a major arc. That is larger than half the circle. Major arc. One more time, it was J to L to M. So I'd have to add up the 120 and the 60. That's 180 plus another 65. That's 245 degrees right there. So we'll put 245. Let me just make sure that makes sense. Yep, that makes sense. Next, we're going to find NLK. So N's right there, L is right there, and K is there. So we're going to go in that order. NLK. So we're going to take the 65, the 55, and the 60. That looks like it's half the circle. Now, I'm not exactly sure. So what I'm going to do is I'm going to go ahead and add them up and see if it comes out to 180. So 55 and 65. Yep, that's half the circle right there. So what we're going to call this one here is a semicircle. That means half the circle. Semicircle. And semicircle is always equal. Sorry about that weird looking E. Always equal 180 degrees. And our final one is LMN. There's L, go to M, then go to N. Oh, you tricky little problem here. They gave us three letters, which is totally viable. You can totally acceptable. But usually it's when you have angles more than 180. Now this is less than 180. That means it's going to be less than half the circle. So we're going to call this one here a minor arc, even though they use three letters. A minor arc. And we're going to add the 55 and the 65 together, which gives us a total of 120 degrees. All right, let's move on. Moving on to question number 12. Find the radius of the circle. Ooh, this guy's kind of tricky here. So what I notice in this problem is we have two chords. We have the chord ST and the chord VU. Now, since they're both 18 away from the center, that means they're equidistant to the center, they must be congruent to each other. So I'm going to start off this problem by saying that those two chords, right, those two chords right there, are equal. So we're going to say the 6x minus 5 is equal to the 13 plus 4x. And we're just going to go ahead and solve this guy, moving all the x's to one side of the equation and all the numbers to the other side, or non-x's I should say, to the other side of the equation. And this gives us 2x is equal to 18. Dividing both sides by 2, we find out that x is equal to 9. So I'm going to take the 9, I'm going to plug it back in. 6 times 9 is 54. Take away 5, and that's going to give us 49, I think. I'm going to double check my answer here. So I'm going to take the 9, plug it in. 9 times 4 is 36. 36 plus 13. Oh my gosh, this is an ugly problem. We get 49 for sure. Now the reason why this problem's ugly because we're about to cut this thing in half. So to find the radius, let me zoom this guy in because we're going to want to take a closer look at this. To find the radius, we could draw pretty much any radius we want, right? It doesn't matter which radius we draw. We can draw any of them. They're all exactly the same. So it probably makes the most sense to draw the best radius. And the best radius is the one that forms a right triangle with the other two pieces. So I know that one side of the right triangle is 18. I know the other leg of the right triangle is 49. we know it's not 49. That's the whole chord. We actually know it's half of 49. So we're going to take half of 49, which is hella ugly. It's going to be 24.5. So we're going to say that this guy here is 24.5. Disgusting. That means we're probably going to have to use a calculator. And now we're going to use Pythagorean theorem here. Remember, Pythagorean's theorem states that the longer of the two sides, also known as the hypotenuse, that guy right there, if you square it, it must equal the two smaller sides, the 18 squared and the 24.5 squared, but added together. So that's what we're going to do. We're going to go ahead and take out our calculator and we're going to do the math on those guys right there. Let's see if I got my Desmos going on. Sorry. There it is. So we're going to go 18 squared and 24.5 squared, and I'm going to add those guys together. So we're going to go 18 to the power of 2, and then I'm going to add that to 24.5 to the power of 2. So that's 924.25. So we get equals 924.25. And now we have to square root both sides of the equation to get rid of the square. So we square root both sides, and we're going to find out our radius. Sorry, looking for the black pen here. We're going to find out that our radius is equal to, all right, so go back to Desmos, and hit that square root guy, and then type in 924.25. Yeah, it's an ugly answer, but that's totally cool. We're going to go 30.4. So our answer for this problem here, the radius is 30.4. Let's see, let's go full screen. And that is question number 12. The radius is 30.4. Moving on to question number 13. Find x and y. Now this guy seems kind of complicated, but it's stupid easy. All you have to remember is that the angles on opposite sides of the quadrilateral will always add up to 180, as long as it's inscribed in the circle. That just means as long as the corners all are on the circle. So I notice that this four-sided shape, the quadrilateral, all four corners hit the circle side. Well, then that means the red angles, the ones that are opposite to each other, must be supplementary. In other words, they must add up to 180 degrees. I can say the same thing for those blue ones. The y and the 113 must add up to equal 180 degrees. Now I know a lot of you just take the 180 and subtract 70 and you get 110. That's totally fine. You can do that. So we know that y is equal to 110. But if you wanted to, you can also use the equation form. And then we're going to do 180, take away the 113. That's going to give us 67. So you can say that y is 67 degrees. And that's question 13. Let's go ahead and take a look at question number 14. Find the measure of angle K. This is actually a pretty easy one. Now remember, if the angle is not in the center, then it does not equal the arc. In this one here, we have to divide it by 2. So this guy right here is the 40 degrees cut in half, which is 20 degrees. So my answer is that the measure of angle K is equal to 20 degrees. Not too bad. Moving on to number 15, kind of like that guy, but backwards. So this one over here, this one we have the angle. So when you have the angle, it equals the arc when it's in the center. But if it's not in the center, you got to do a little manipulation here. So we take the angle, 72, and we double it. So if you double the angle, you're going to get the arc. 2 times 72 is 144 degrees. All right, hopefully this made sense. If it didn't, I'll be in school on Friday pretty early in the morning for anyone that wants to come by and ask questions. Otherwise, I'll see you in the next video to help get those next couple of questions done.